take a moment to get into your workbook on page S22, and where you are going to work on exercise 2 on your own using the same process as you did for example 1. Now that you had a chance to do your work and enter your answer into the program, let's take a look and check your answer. Here we have our center point O and ray OA, and here it says we have a scale factor of 4. So we're going to use what we know about FTS to find the location of point A prime, just like we did in example 1. All right, so I'm going to start here, and I'm creating my new ray from center point O along the x-axis. And I'm going to drop a parallel, or drop a vertical from point A down to 3. And I know since I have a scale factor of 4 and I have a length of 3, I can quadruple this or multiply it by 3. Or I mean, excuse me, 4. So I can say 3 times 4 is 12. So I'm going to extend this out, find 12, make a point. Bring up a vertical, and there's my new point, A prime. Now what's nice about this is it's exactly on an intersection of the grid lines, so I can see there that my new point is at 12, 12, and my original point is at 3, 3. And I can see that if I take my original points and multiply them by 4, I get my new points. Okay, let's take a look at example number 2. Take a moment to white out where it says white out current A. And instead of using an integer, we're going to use a scale factor that is a fraction. So our scale factor is R equals 11/5. Okay. Take a minute to look at the scale factor and decide what you know is going to happen. Is it going to get bigger, or is our dilation going to get smaller? Excellent. Our dilation is going to get bigger because our scale factor is greater than 1. Okay, so again, I have my second ray coming out of my along the x-axis from point O. I'm going to drop a vertical from A and create a point. Now let's backtrack for a second and let's remember how we find scale factor. When we want to find scale factor and we're only given measurements of 2 items, we take our new image and put it over our original. So we can relate this to our scale factor and take a look. Our original image is 5 spaces long. So then our new image is going to be 11 spaces long. So I'm going to create a point at 11 and move it up. Always leave this as a fraction. Decimals, when we're talking about dilations, are a little bit too difficult to work with at this point, so leave them as a fraction. So we have 11/5, and we've brought our point up. Now, our new point doesn't exactly lie on an intersection point of a grid line, so we can't exactly give ourselves a name for this point, a coordinate for this point, because it won't be exact. We could say, oh, that's about 4.5 on the y-axis, but we need to find something more exact. So we're going to take our coordinates for A, which are 5, 2, and we're going to multiply by our scale factor. So we're going to start with 5. I have a whole number times a fraction, so I drop a 1 under that. And I multiply everything straight across. 5 times 11 is 55. And 1 times 5 is 5. You could also cross reduce if you choose to do so. And 55 divided by 5 is 11. So that's my x coordinate of my new point. Now I'm going to take 2 and also multiply it by 11 over 5. Drop a 1 under that. Multiply across. And I get 22 over 5, or I could reduce it to 4 2/5, which you can see is much more exact than the 4 1/2 you would probably end up guessing. You're going to take a moment now to go back to your workbook and go into exercise 3, where you're going to do this very same process on this drawing here using a scale factor of 5. Now that you've had a chance to take a look at and work through the problem and enter your answer into the program, we're going to check your work. You have your ray, so we're going to create another ray along the x-axis. Now my scale factor this time is less than 1, so that means my dilation is going to be smaller than the original. So I'm going to start by dropping my vertical, which is always my starting point, and remembering that scale factor is new over original. I know that my original is at 12 and my new is going to be at 5. So I'm going to bring up my vertical from there. And again, I'm not on an intersection of grid points, so I'm going to have to do some calculations. My original point is at 12, 8. So I need to take each of those and multiply them by my scale factor. So I'm going to start with 12 times 5 over 12. 12 times 5 is 60. Oops, I forgot to bring my 1. 1 times 12 is 12. And if I reduce that, that equals 5. Which we already know because this lies on the x part of the x, or the 5 on the x-axis. Now I'm going to take my y coordinate and multiply it by our scale factor. Drop a 1. 8 times 5 is 40. 1 times 12 is 12. You could also cross reduce if you choose so. You reduce by dividing everything by 4, and you get 10 over 3, which also turns into 3 1/3. Excellent. On to example 3. Example 3